So when we were talking about quantitative data, we said that we would talk about the key features of the graph, such as the center, the spread, the shape, and outliers. We talked about the shape. Now we're going to talk about the center. So when we're talking about the center of a distribution, there are three ways that we can describe the center. The first is mode. It occurs with the greatest frequency. It occurs the most. Mode, most often. Mode is used most often. This is mainly going to be with qualitative data. Companies would want to know which product is being sold the most often, or what category is being sold the most. So we don't tend to focus too much on the mode with quantitative, but it is one way to describe the center. Arithmetic mean is another way. So there's some notations that we'll need to talk about. The mean is the average, and it is found by adding up all the values. So this symbol means sum. X is used to represent the data values. N is the number of data values in a sample, and capital N would be the number of data values in the whole population. So X bar, X with this little bar over it, is the mean of the sample. And so you would add up all of the values in the sample, and then divide by the number of values in the sample. So you add up all the values divided by how many you have. Now, if I'm doing that with the sample values, is that a statistic or a parameter? That's a statistic. Now, this crazy symbol, this is the symbol mu, mu, mu. It represents the mean for the population. So you'd add up all the values in the population divided by how many you have in the population. Is that a statistic or a parameter? What's a parameter? More times than not, we know the sample values, and we're using this mean to estimate the mean of the population. Now, another measure of center is called the median. And this is used with samples. It's the middle value when arranged in order. So they have to be arranged in order. And sometimes they'll be denoted with an M or with an MED. And we'll review how to find the median here in just a second. Mode is easy. It's the one that appears the most. So let's say we have, this is all 10 students enrolled in a section of introductory statistics. So this is the entire population. And we want to compute the population mean. So the symbol for the population is, it's like a U kind of thing. It's a fancy M, actually. It's mu. And we'd add up all the values and divide by the total number in the population. So we're going to add up all the values divided by all 10 students, divided by all 10. So clear, we got 82 plus 77 plus 90 plus 71 plus 62 plus 790 divided by 10 is 79. Now suppose we take a sample That turns it into X bar. That's a sample set. And so we're taking a sample, and it said, let's just take, who all? Ryan, Dave, Joel, and Sam. It's only 4 people. So we're going to add them up and divide by 4 this time. So 77 plus 68 plus 74 plus 84 is 303 divided by 4, and we get 75.75 for our sample mean. Now determining a median. The data in the table represent the length of a random sample of songs released in the 70s. Find the median length of the song. Now to find a median, you have to have them written in order. Smallest to largest, or largest to smallest. I'm going to go small to large. So the smallest is 179. Next one would be, and then 201. And 206, and then 208. Some people prefer to write them left to right. It doesn't matter. 217, 222, 240. 257 and 284. Now how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the middle one would be right here. 4 on each side. The median is 217. Then it says find the median from the data in table 1. So I'm going to look back up at table 1. That was those test scores. Alright, so those test scores. The smallest one was a 62, then a 68, then a 71, then a 74, 77, 82, 84, 88, 90, and a 94. And this time we have 10. So to find the median, there's an equal number here and here. The median is right in the middle, right here. So when you have an even number of observations, the median is going to be in between 2 values. So we would actually find the average of those 2. An average, you add them together and divide by 2. And that's 79.5. I want you to notice how close that is to the actual population mean. The median and the mean are very close together. Now I mentioned that mode is used mainly for qualitative, while mean and median are used for quantitative. But which one do we use? Which is better? Well, sometimes we have extreme values, outliers. And if those values do not affect your number, it's said to be resistant. So when you have skewness, skewed right or left, that means we have extreme values in that tail, whichever direction it is. For example, if we have skewed to the right, that means we have larger observations in that right tail, and it's going to pull our mean to the right. vice versa. If it's left skewed, it's going to pull the mean to the left. So the difference is that the mean is going to be shifted. So the mean is not resistant. The median is. So I'm going to make a note. Mean is not resistant. Median is resistant. So look at these graphs. So the mode is always the one that's the most, so it's always the tallest part. When we have left skewed, the mean is being pulled to the left, so it's less than the median. And if we're right skewed, the mean is to the right of the median, so the mean is greater than the median. If it was perfectly symmetrical, all three of them would be the same. The mean, median, and mode would meet up right in the middle. So if we are skewed, we're going to prefer the median to the mean. So I'm going to make a note of that. If skewed, use median instead of mean. Because the mean is being pulled by something. So it's not going to be as accurate. Notice the median is closer to the middle when they're skewed. Well, you're probably thinking to yourself, so why would I ever want to use the mean? I mean, well, most of the time we're asked about the average. People want to know about the average much more than they want to know about the median. So we tend to prefer, when we talk about inferences, the mean. So we'd much rather the data be symmetrical so we can use the mean. And we'll talk about how to test for outliers and maybe take those out of the data to make it more symmetrical. So for these, it's just asking us to find either the population mean or sample mean. So first off, just sample, we're going to use that notation. Population is going to be this fancy mu. And I will let you pause and try them, and then you can check your answer. So hopefully you got those right. All right. For Super Bowl, is that Super Bowl 40? CBS Television sold 65 ad slots for a total revenue of roughly $162.5 million. What was the mean price per ad slot? So since this is the total revenue, and this is the number of ads, the mean price per ad would be the price divided by the number of ads. The following data represent monthly cell phone bills for 6 randomly selected months. Compute the mean, median, mode. Okay, so I went ahead and calculated the mean, added all 6 up and divided by 6, and I calculated the median. If you put them in order, the 2 middle ones would be these 2, and this is the average of those 2. Is there a mode? None. There is not a single number that appears more than once. The following data represent the travel time in minutes to school for 9 students enrolled in Sullivan's College Algebra course. Treat the 9 students as the entire population. So compute the population mean for travel time. And then you pick a sample size of size 4 and compute a sample mean. Hopefully you paused and you added these up and divided by 9. And I got now for your simple random sample, it doesn't matter which ones you picked. I'm going to let you have that. Okay, so here's a little bit of a breakdown. Mean. Your mean is your true average. And then we use the mean when we are symmetrical. Median. That's literally dividing the bottom half from the top half. And we're going to use this when we're really skewed. Okay, so if we're skewed, that's when we use median. Mode is mainly used when we're qualitative, because you're just looking at how many you have that are total.